Okay, everybody. Today's section is called scatter plots, and the reason why we call this scatter plots is because we're going to be taking some data and putting it on a coordinate plane. And what the pattern you're going to see, or the data once you get on there, is going to be kind of scattered about the plot. All right, and you see I gave you a little definition on your note packet. I didn't put it up here, but basically, we're taking this data, this large amount of data, and we're going to put it all on one coordinate plane. Now, up till now, our data, or our points, or our coordinates that we've been graphing, they usually form a straight line. They all line up, or a nice curve like a parabola. But this data, this is real-time data. This is actual data, and so in the real world, things don't always line up real nice. Okay, so what we're going to do is we're going to plot this on our coordinate plane that I have set up for you, and we're going to see what kind of trend, or what we can gather from the plot itself. Okay, but today is just simply putting it on the coordinate plane and looking and see what we have. So one word I want to mention, though, one word is the use of bivariate data. I didn't mean to cross that out. I just want to put a little line here. The use of bivariate data. Okay, and that's a different word for us. We haven't seen that before. But if you think back to English class, that prefix bi means two, and if you look down here, we have two sets of data here that we're graphing. So that's why we're calling it bivariate data, because you really have two sets of data you're putting up here. All right, and the data that we're looking at describes 13 different car models. So here's the number of the car model, and it lists two things, like I said, bivariate, two things about each one of these models of cars. All right, it lists the weight, and it lists the fuel efficiency, the miles per gallon that it's getting. Something very important to people now that gas prices have gone way up. So, all right, so here I need to move this out of the way. I can't fit both of these on the screen. So let me get rid of this and put up the coordinate plane. All right, guys, here's the coordinate plane that I've got set up for you, and I'm not going to make you watch me plot all of the points. That'd be kind of redundant. I'm going to do the first couple, and then you can go ahead and pause the video, and then I'll just skip ahead and get all of them on there. But if you notice along the bottom, we're not going by ones. We're going by 20s, I believe, along the bottom here. So this is like, no, we're not going by 20s. We're not going by 20s. We're going by 50s. Sorry about that. Because this is 2,500 up to 3,000. We're going by 50s along the bottom here. So every two blocks is 100. Okay? So if I want to go up to 2,550, well, 2,400, or sorry, 2,600 would be right here. 2,550 is the first block past 2,500, okay? And then I want to go up to 28. So follow right up to 28 and put a dot right there. Okay, if I can get one to show up for me. There you go. Okay, and then I want to do 4,050. That's Model 3. 4,050 would, again, be the first block past 4,000. So, and that has a fuel efficiency of 19. So I'm going to go up to 19, which is right there. Let's make sure I'm on the right one. Okay, I need to put a dot right there. Okay, and let me do another one. Oh, this next one is also 4,050, and it has a fuel efficiency of 20. All right, so apparently there are two different models. Oh, I'm going to fix that one a little bit. There are two different models of cars that have the same weight, but they have a different fuel efficiency. All right, so go ahead and pause this right now. I'm going to do the same with mine so that I can then come back on and you'll have all of these graphed on here. So, like I said, go ahead and pause it and graph them yourself, and we'll be back right here in a minute. Okay, and as you can see, I put the rest of the points on here. All of my little dots represent a different model of car. And you can see what's funny is we have three different models that have different weights, but they have the same fuel efficiency. Okay, that would be model 9, 11, and 12. Okay, so that's kind of weird. All right, they have different weights but the same fuel efficiency. Okay, and then you have these two that have the same weight, and again, they have different fuel efficiency. Did I say that right? They have different weights, and they have the same fuel efficiency. These three, these have the same weight, but they have different fuel efficiency. So it's just very weird. Okay, so this is our first scatter plot that we've made. Okay, and really we're not going to do anything with that right now. We're just going to say, okay, hey, here's my scatter plot. You can see there's kind of a trend though, right? What we're eventually going to get to is you're going to draw a line through these. You can see it sort of follows that as your weight goes up in your car, right? The car is heavier, the fuel efficiency tends to be going down. See, the ones that are lighter over here have a higher fuel efficiency than the ones that are heavier over here. So you can kind of see a trend there. All right? All right, so easy enough. Let's go on to example 2. All right, guys, here is exercise 2. And very similar to what we did in the previous exercise, they give us a set of data up here, and it is dealing with shoes in this case. And we've got 10 different types of shoe, and here's our bivariate data set. You notice two quantities again. For each shoe, they're giving us a price and a quality rating based on a consumer survey. All right. So we want to do the same thing. We want to create a scatter plot. Now I went ahead and labeled my y-axis. You want to do the same thing. Since we only need to go up to 71 was the highest rating, I thought, well, it'd be kind of silly to go by something by like 5s, because that would really make the graph very small in this coordinate plane here. So I went every other block was 5. So you want to pause the video here and label that y-axis, and then we'll go ahead and plot the points. All right. So I'm going to do a couple, and then like I did in the previous one, I'll just skip ahead and get them all plotted on here for you, so you don't watch me do all of them. So shoe number 1 is $65. So this is nice. It goes by 5s along the bottom here. $65 and 71 rating would be just above the 70 points. So I'm going to put a dot right there. Okay, and the second shoe is $45, and it gets a 70 as a rating. So 45 is right here, and 70. And then 45 again got a rating of 62. So that one is going to go, let's see, 62 is going to be about right here. About right there. Okay. And again, I'm gonna pause my video and fill in the rest. So you guys go ahead and pause the video, fill in the rest, and then we'll jump right here in a second to all of the plots plotted. All right, so now I've plotted the rest of the points, and you can see why this kind of thing gets the name of a scatter plot, because these points really are scattered about this graph, and there doesn't really seem to be much of a pattern here. All right, you would think that the higher priced dollars, the higher priced sneaker or shoe, would get a better quality rating. But if you look at these points, we've got $80 shoes that got a low 50 and a high 50. We've got $110 shoes that got a low 50 and some high 50s as well. We've got a $45, two pairs of shoes, $45. One is in the low 60s, I believe it's 62, and another one that gets a rating of a 70. So you can see they're kind of all over the place, all right, and hence the name scatter plot, right? So they do ask a question that goes along with this. Let me turn that on. They do ask, do you see any kind of relationship between price and quality? Well, for this one, I would say no. I really don't see a relationship because, like we were just saying, you've got shoes that cost the same and they have very different quality ratings. And if it was a positive relationship, or there would be some kind of relationship as price got bigger, maybe you see quality rating also get bigger. So you'd have like a trend that went up. Or it could have a negative relationship. Some things have a negative relationship where as X got bigger, the quality or the Y got smaller. So you'd see kind of all of these points going down to the right. So with this one, I really don't think there's a positive or negative or a strong relationship between the price in dollars of the shoe and the quality rating. So for this, I would say no for this myself. All right. So okay, so that's exercise 2. Let me get rid of this, and we have one more to do, exercise 3. So right after the jump here, we'll tackle that one. All right, here is exercise 3. Now this one just a little different, actually really easy compared to the other two because we don't have to graph anything. So it says data were collected on students' shoe size and the score they have achieved on a second grade reading test. Now, if you just stop right there and don't even look at the graph, think about, I wonder if there is a relationship between your shoe size and how well you did on the reading test. All right, and that's what they're kind of trying to show you here. Is there a relationship, or does it just not make any sense at all? All right, so the scatter plot of these data points is shown below. Does there appear to be a statistical relationship between shoe size and score on a reading test? All right, and if you look at these points, so here's the shoe size. We've got some at a 5, and it looks like these are 5.5 and 6 and 6.5. That's usually how shoe sizes go. They go by half step, right? So it would make sense that we have a grouping straight up from 5 and a grouping straight up by or from 5.5 and 6 and 6.5 and 7, etc. All right? And then you look at the scores over here, and it looks like if I were to try to draw a line in here, it looks like, and I try to draw a best fit line, it looks like it would go something like this, wouldn't it? All right, that would be touching a few of the points, and we've got some points above and some points below. So it looks like to me that, wow, there does seem to be a relationship between shoe size and reading score. But sometimes, sometimes these graphs don't really show the entire story or explain the entire story. Okay? I mean, really, if you think about it, if you put it in the context of the problem, what does shoe size have anything to do with the reading score? Does it necessarily mean that, oh yes, the bigger shoe size you have, the better you're going to do on the score? All right? Well, maybe you have to look at some other variables here. It says explain why it is not reasonable to conclude that having big feet causes a higher reading score. All right, I hope not, because everyone with little feet, man, I guess we just say they're bad readers, right? Well, no, that doesn't make any sense. What can you think of a different explanation for why you might see a pattern like this? Well, let's think about in school. When do you start kindergarten? All right, usually you start kindergarten when you are 5 years old, right? And usually, if you are in first grade, you are 6 years old. Okay, and we could do this all the way up through, and either you might be turning 6 during that year, or maybe you just turned 6 in August, or in the fall, and maybe at the end of first grade you actually are 7 if you have a really late birthday or something like that. Like in May or June. All right, so it's an approximate. Usually, when you add 5 to the grade, that's the normal. I shouldn't say normal. That's the average age, you are in a certain grade, all right? And it depends on your birthday and everything. But if you think about it, as you go from 5 years old to 6 years old to 7 years old to 8 years old, well, what usually happens to your shoe size? Well, your shoe size usually, right, as you go and you get older, usually shoe size gets bigger, right? Usually shoe size gets bigger as you go throughout the grades. So wouldn't it make sense that someone that has a shoe size of a 5, and if we compare that to someone with a shoe size of a 9, it probably means that this person with the shoe size of a 9 is older, right, than this person with a shoe size of a 5. So it would make sense that they would do better. All right, they would do better on the reading test because it is a second grade reading test. All right, it didn't say that they only gave it to second graders, right? So this could be older kids taking that second grade reading test. This could be younger kids. Maybe, 5 years old, you're in kindergarten. Maybe this kindergartner class, we said, we're going to give the second grade reading test to these kindergartners to see how they do. Well, of course they wouldn't do as well as these guys over here. So, you have to put it in the context of the problem. All right? Yes, by just looking at the graph, it absolutely looks like there's some kind of relationship there, right? But probably not dependent on shoe size. At least I hope not. Okay, all you people with small feet are saying, I hope not, I hope not. All right, so when we do all of this data collection and stuff, you can make data look like really anything you want it to, but you have to put it in the context of the problem. All right, so no real math to do there. Just kind of like look at this graph and tell us what you think, and come up with some other reasons why the graph could look the way it does. So, all right, so that's a little introduction to scatter plots for you. What we'll ask you to do tomorrow is actually take some data and put it on a coordinate plane and create the scatter plot and answer some questions about it. All right, so have a good night. Thanks for watching. We'll talk to you soon.